Welcome back. Here's another problem that you'll see in the test. This time we're finding equations of lines that are perpendicular to a given line. So let's start by reading the problem and figuring out what they want us to do. So it says, find an equation of a line that's perpendicular to this one and that also passes through the point 3, 5. So we want an equation of a new line that's perpendicular to the one that we have here. So the key is to look at the slope. If the slope they gave us is 2/3, and we want a new line that's perpendicular to that, our new slope has to be the opposite reciprocal of 2/3. So the opposite reciprocal of 2/3 is -3/2. That's what you need to remember for perpendicular lines, that perpendicular lines have opposite reciprocal slopes. The y-intercept is not known for now. Most, this is be a b. My pen slowed down, and so it's a messy b, but it's still a b. Most students that I see at first want to put 5 here for the y-intercept, but 5's not the y-intercept. If this was a 0, 5, I would agree that 5's the y-intercept, but it's not. It's a 3, 5. So 5's not the y-intercept, and we don't know what the y-intercept is. So for now, we just got to put right here plus b. So keep that as plus b. But the 3, 5 is still useful because 3 is an x-coordinate, 5 is a y-coordinate, and we can use that in our equation to find the b value. So let's plug in 5 for the y value. The slope stays the same, it's -3/2. And for the x value, the x value is 3, so we'll put in 3 for x. And then still plus b. b is still not known. Then from here, to multiply fractions from the first video, straight across, -3 times 3 is -9. 2 times 1 is 2, so we got -9/2. Everything else stays the same. Let's bring our work up here. So we got 5 equals, now instead of writing it as -9/2, -9 divided by 2 is -4.5, so I'll put 4.5 here, and then plus b. And to finish solving for b, we need to add 4.5 to both sides of the equation. These guys cancel out. 5 plus 4.5 is 9.5 equals b, and we're done. We just need to write the final equation. So our new equation is y equals a slope of -3/2 x, then plus a y-intercept of 9.5. Now let's go to fooplot and verify that this line really is perpendicular to the given one. So we want to see if this line is perpendicular to this one, and also make sure this line goes through the location 3, 5. So let's go back to fooplot and enter y equals 2/3 x plus 1. So here's fooplot. If you haven't seen this yet, it's an online grapher that's free. It's www.fooplot.com, and it lets you graph up to 5 equations. So our first equation was y equals 2/3 x plus 1. So we'll enter 2/3 x plus 1. Use parentheses around the slope just to be on the safe side. And then our second equation that we found was y equals -3/2 x plus 9.5. So enter that as a blue equation. -3/2 x plus 9.5. And there we go. So let's make sure that our new line, the blue line, is perpendicular. And I'd say this does look like a 90-degree angle. If we mark this off, it's looking pretty good. That is about a 90-degree angle. So we've got our 90-degree perpendicular going. The second thing we wanted to make sure was that our blue line goes through the point, I think it was 3, 5. So let's go over on the axes here. Go over 3, up 5, and sure enough, the new line that we created, it does go through 3, 5, and is also perpendicular to the other line. So our work is correct. We found a new equation, y equals -3/2 x plus 9.5, that's perpendicular to the given line, and it goes through this point. And we did it all with algebra. So next, let's create a problem of our own. And you can do this on your own to practice as many problems as you want. So instead of y equals 2/3 x plus 1, let's make up a new problem. So scratch this out. Let's go with y equals, let's say, negative 1/2 x and plus 4. And then let's say it goes through the point negative 2 comma 1. All right, same procedures as before, but this time try this out on your own. If you get it right, then you're good to go. But pause the video, try it on your own, and see what you get. Welcome back. So here's a quick solution to this problem. Start off with the slope. Y equals, to be perpendicular to this slope, since this slope is negative 1/2, a perpendicular slope has to be the opposite reciprocal. So it has to be positive, and instead of 1/2, it's going to be 2/1. So 2, and there's no reason to write the over 1 part unless you really want to, but 2/1 is the same as 2. I'm going to keep it as 2. And then still x, but then plus the y-intercept is not known. To find the y-intercept, we can use this location they gave us. Negative 2 is an x-coordinate, 1 is a y-coordinate, so let's plug these in for x and y to solve for b. Plug in 1 for y, right here. Still have a slope of 2, and the x-coordinate that matches a y value of 1 is negative 2. And then finally plus the unknown y-intercept. So 2 times negative 2 is negative 4. Everything else stays the same. And to solve, it's the usual steps. We need to add 4 to both sides. Plus 4, plus 4. The 4's cancel out. We've got b equals 1 plus 4 is 5. So we found the y-intercept. We already knew the slope was 2. So our final equation is y equals a slope of 2 times any given x value, and then plus a y-intercept of 5. So let's go to fooplot and verify our answer to make sure that it's correct. So going back to fooplot, we're going to enter the original equation that they gave us, which was y equals negative 1/2 x plus 4. So I'll enter that here. Y equals 1/2 x plus 4. I'll put the negative back in there. The second equation is y equals 2x plus 5. So put my negative back. And then here we had 2x and then plus 5. Let me go back and double check our equations to make sure they're entered correctly. So negative 1/2 x plus 4 is one equation. That was the original. And we found a new equation of y equals 2x plus 5. And it's supposed to be perpendicular to the red equation. And you can see right here that they are perpendicular. So check there. And our new equation, the blue line, should also go through the point negative 2 comma 1. And in the graph, you can see right here, it's hard to see. Let me clear out the lines here, and you can see that it goes through negative 2 comma 1. So if I scroll around down here, negative 2 comma 1 is right here, and our blue line does go through that point. So we verified that everything we wanted to happen did happen. We have a new line perpendicular to the old one, and it goes through negative 2 comma 1. So that's how to make up your own problems. Go ahead and make up 1 or 2 more until you're getting them correct in a row, and you're good to go. Thanks for watching.